Okay. Oh, before I get started, who's my biggest naysayers? All right, it's probably Kimberly, right? Now Smith, he never knows what he's just making stuff up, right? Okay, read the top name of that dude. Lala. Right?
Yeah.
See? All right, anyway. Methylamine. Oh, it sounds better than lalanine. Okay, so the first guy. Does he, of course, here's the name, is he HA or A minus? If I give you 20 grams of methylamine, that is A minus. Good. Okay, that is A minus. Now, I gave you 20 grams of methylamine. You got to convert him into moles. So you need to know what the structure is. What is his structure? What's his chemical formula? CH3NH2. All right? Okay. Okay. Methyl Annalynne.
I thought you wanted us just to write the structure. That structure right there, we always confused.
No. I said the structure of the name. I also said structure of the neutral form. I told you too much. I told you too much. That's why I was trying to stop myself. Okay. Methyl Annalynne. Is that the conjugate acid or the conjugate base form?
Conjugate base.
You got to rip off an H plus again, right? Does everyone see that? It's got the plus. You got to rip it off. It's not neutral. You can't have a bottle of that stuff sitting around. You could if it was the methyl aniline. What's the second word? Chloride. If it said 2-methyl aniline chloride, you can have a bottle of that. That'll work. But it's not. You have a bottle of methyl aniline. Okay, and its structure, just rip off the, well, yeah, the H plus technically. All right, you got your methyl and your amine. Okay. How about 4-methyl aniline? Yeah, same thing, right? Rip off. And that should take it organically. NH2CH3. All right? So you can find the molar mass of this stuff. That's the whole point of drawing the structure, because you're going to have to do that if they gave you grams of it. The last one, he definitely is what form? The acid form. HA. So that is a structure. Just copy. It'd be the same thing. No. Okay, leave them alone. That is the neutral form. So just copy this guy. Copy him. Okay. So when we start working these problems, yes. Here.
The structure that you wrote down is the structure for the name?
For the name, for the neutral form. Yes. Because they could do that. They're going to give you 18.9 grams of 4-methyl aniline. And if you don't know what the structure is, you can't convert it into moles to make a mole table. Okay. Now, one last little step before we go on to some questions. I give you 250 milliliters of 0.8 molar methylamine. Are you going to add, who knows to what pH they're adjusting, right? It really doesn't matter. Are you going to add HCl or NaOH to adjust this pH? You can only add HCl because all you have is a conjugate base, right? All you have is a conjugate base. So all you can add is HCl. All you can add is HCl. All you can add is HCl. All you can add is NaOH. Make sense? Okay, so that's the game we're playing. Let's see how good you are at it. Mr. Negative. Okay. Here's our buffer problems. More practice. we're gonna, if a known amount of strong acid or strong base is added, what's the new pH? Again, make a mole table. How much of a particular strong acid or base? How many milliliters of this 0.28 molar potassium hydroxide do I need to add to this buffer to get the pH a certain value? Again, mole tables. And we're going to use our revised version of the Henderson-Hasselbalch equation, right?
The mole table is the same thing as ice, right?
Exact same thing as ice. Except we don't use concentrations. We want moles in there.
Oh, okay.
That's a strong point. We don't want concentrations in there. We want moles. Okay. Here's the first one. We'll hand out C, so I guess this is homework or something, right? But we can get you started. Turn on some lights here, get you started, and then we'll let you have at it. Okay. How many milliliters of 2.45 molar KOH? Well, I have some paper up here from that quiz if you want some paper. I have 2 sheets. So generous. False advertising. I don't know. Here. Okay. Oh, here's another one. 3. Okay. First, we got to find it in our appendix, right? So on any exam or quiz, you're going to have to be given this, photocopies of it or something. So you got to find pyridine, and let's just have Casey find it for us. She can tell us what's going on. Pyridine. Okay. So, Casey, does that correspond to HA or A minus? She said it's A minus. That means everybody, not Casey, there's an H plus in the table, right, Casey? Okay. So that corresponds to A minus. So if you want, this is where it's your call, whatever you feel the most comfortable doing. We need to write a reaction and do an ice table. Well, sorry, a mole table, it's the same thing. But okay. You can write the structure from Casey of pyridine and put it up here. Or you can just write what for pyridine? A minus. That's your call. I'm just going to write A minus because I have no idea what... I should know what pyridine is, you think by now, right? That's not sad. I just have horror memorizing anything. Okay. So, you can write the structure from Casey or write A minus. What's the reaction? Plus what? All right. Now here's okay. Now do you see what Pedro's starting to talk about though? Oh, add water. He wants to write a KB reaction. Not wrong reaction. We want to write a reaction with this dude or with this dude, right? With the HCl. And the reason why we have to write that reaction is look at the question. It's always like this. How many milliliters of this stuff? Well, you have to write. That has to be a reactant, one of those guys. It's going to be like that every time. If you're going to adjust the pH, we're never writing the Ka or the Kb anymore. We're writing a reaction of what's going on. We're determining whether our little buffer system corresponds to A minus or H plus, A minus or HA, and then we're going to react it with the appropriate compound, either the acid or the base. And we're going to do a mole table on it every single time. Okay, so that means it's A minus plus. Yeah, you can write HCl or H plus. I think writing H plus would look better. Because otherwise, what do you do with the Cl on the other side? Because on the product side, everybody's going to be HA. And then if you do a little plus Cl minus, that kind of screws up the whole mole table, doesn't it? Get used to, hopefully we've been working on this. When you see KOH, you don't see what element? K. When you see HCl, you don't see what element? Cl, right? So when you see A minus plus H plus, in your mind, you really picture H plus as HCl. But, okay. We need an initial row. So, Randy, what are we going to put in that initial row? Yeah, we will. So we do need the bloody structure. Oh, right? Does it give us the formula mass in there? It does? No way. I thought it didn't. No, it doesn't. No, it doesn't. Mm-mm. Okay, so that means, Casey, give the book to Adriana, and she's got to tell us what the structure is of this thing. What is it? Do I draw the aromatic ring thing?
Yeah, you're going to draw an aromatic ring.
Okay.
But
And what's connected to it?
on meta, you want NH plus.
Okay, I don't know what meta is. Probably this thing, right?
It's relative.
It's all, it doesn't matter, right? There's nothing there. But it's really just,
It's in the aromatic ring. That's why.
what's in that table exactly, so that everyone's clear?
Oh, okay. It's in the bonds. Like those two are bonded together.
Really?
Yeah, look.
I probably... Oh, the N is in the ring. No wonder. How would she explain that? That is a hard one to explain. Well, you'd say that replace one of the carbons by the nitrogen. It's in the rings. All right. Now, let's write it exactly. That is what the book looks like, right? Where's pyridine? Yeah, that's what the book looks like. So we want to find the molecular structure of not this, but what? Erase what? Erase the H plus. Get that N in there. All right? Let's put in our... So what's the formula for it? It's got C's, it's got H's. I know it has one N. C5.
1, 2, 3, 4, 5. No. 1, 2, 3, 4. Because the circle means the double bond, so then
The alternating double bonds, conjugation.
there's 2.
Isn't it 600?
This, just to remind you, that is C what, H what?
C6H5? Aromatic benzene C6H5.
No, there's no, it's all carbons. C6H,
Oh, H is what?
all right? Double bonds, right? They're conjugated.
So then we're going to
If you, so we're going to have H. You have an H here. You have an H here. No, you can't Google on the exam, though, right? Right? My organics aren't that weak. Your guys is worse than mine. That's horrible. All right. Remember this? Now, if you're not sure of this, you should probably draw a benzene. Get rid of that circle. Right? Put in your alternating bonds. Write your CHs. Right? That's really sad, isn't it? And the world can see this with... Okay. But... Okay. So now that you had your fun for the day... Does anyone disagree with C5H5N1? We're all on the same page with it. Okay. All right, so we got it. So we need the molar mass of it. See, that's 60, 65, and 14. That's like 79, right? Okay. So 3.85 grams times 79 goes on the top or the bottom? Bottom. Get those grams to cancel. Grams in a mole. Okay. So your Andy's right. We got to figure out the number of moles of that stuff. .85 divided by 79, about 0.0487 or so. Right? Okay. What else should we do, Danielle, to finish out this initial row? Thank you, Big John. All right. Change row. Kat, how are you going to fill that out?
Well, isn't it gonna be minus x?
Yeah, this stuff is reacting. It's reacting. Yep.
And H plus is going to minus x2.
Technically, and then HA. Remember, this guy didn't really make a whole lot of sense because we're adding them. But I guess it kind of makes sense for minus x because whatever we add reacts, right? So that kind of makes sense. But it's kind of weird. You don't have anything there initially, but you're adding it. And whatever you add reacts. All right, so now we can finish this guy up. 0.0487 minus x. But remember, he doesn't even show up. That H plus doesn't even show up in our Henderson-Hasselbalch anyway, so we really don't care. Right? All right. Now let's put everything in to our Henderson-Hasselbalch. Well, you can do that.
The one that has the arrow.
Oh. Okay. So find the Henderson-Hasselbalch equation. Right? pH equals pKa plus the log of the moles over the... We're going to need... Who has my book? I do. We need the pKa. It's 5.2. The pKa is 5.2 for this pyridine. So put all this stuff, your mole table, into our Henderson-Hasselbalch equation. Put it all in there.
What's a pKa?
5.20. 5.2.
So we're solving for the HAs.
Now, maybe before we substitute in, how is this going to help us get our answer? How many mils of... Oh, I have to erase that KOH. I didn't mean to circle that.
So we solve for the moles of HA, and then we plug that in with the molars of HCl.
Molarity of HCl. Now you could see here what Nyla said? Just technically she's a little bit off. She said get the moles of HA and then use the molarity of HCl to get it. Well, technically not really the moles of HA, the moles of H that you added, right? So but they're the same number. They're both X according to our mole table. So we're going to get X. That's the whole big goal. If you get X, you know the moles of H plus. Well, we know the number of moles per liter of HCl, so we can convert moles of H plus to milliliters. No big deal. So try it. Plug this information in from the mole table into the Henderson-Hasselbalch. Get X. Use X to get the milliliters of that 1.18 molar HCl that you had to add. And if anyone's not sure where to go, just ask. Where to start, what I'm trying to get you to do.
So we're supposed to set it up in this one?
Log. So the moles of the base, which is this one, all over the moles of the acid, which is this one,
So we don't
X.
include this one.
No, he doesn't fit in there.
See, you combine the X's. So it's,
Yeah, so I did the 0.0036 divided by 1.8. Oh, okay. So then, times 1,000 milliliters. That's 1,000. So then, did you get 28.5 milliliters?
Yeah.
So what you do is subtract this to this side.
That's what I got.
And then you're gonna have the negative.
Did you get it to work? 28. So I see a 28.5 mils. Did anybody else get 28.5 mils final answer? A lot of folks are getting 28.5 mils as the final answer.
Is that what you got for X silent? When you have 0.0468 X equals 0.0487 minus the negative. When you add the X to the other side, it becomes 1.
So when you raise the top,
Just double check that my X goes.
Kathleen, what did you get for your X? 0.0336. So if you do your math right, you should be getting 0.0366. Is that right, Kathleen? 0.0336. All right, something like that. Something really close to that for X. Go back to your mole table and see that that is moles of H+. Then use the concentration of HCl to get the milliliters. And you got like 28? Or 28.5, 28.5 mils. Okay. So if you get this first one, go on and see if you can knock out the rest of these, because that's the homework. If you're not sure how to get that final answer of 28.5, just ask. Yep.
I technically got the answer, but I'm getting that. But I mean, I did.
280. Oh, you're off by 10. This guy should be 0.03.
Oh, I probably just forgot the zeros.
Then how
That
is
should
the
be
equation different?
0.03. Somewhere you messed up. Somewhere.
Let me divide it again. Maybe I just
Yeah.
So if we're having to use the KOH because on the second one the phenylacetic acid is in
Acid. Yeah.
does that change our H plus equals our H plus?
It changes your reaction.
Yeah, how do I
So you have to write, now you have an acid, it has to be HA has to be the reactant.
goes
Plus
H plus
OH
plus OH goes to the conjugate
goes to A minus
A minus, the conjugate base. Why H2O? Okay.
Does it not go to
zero here. in here. I had it here, but when I wrote
Oh, okay, good. Good, good.
A minus, and that's it.
When we take the log, we're not supposed to get a negative number, right?
I think technically there is, but.
This is less than 1.
I keep getting a negative number. Like,
That's
I
fine.
got the setup right, I'm not getting the final answer.
This is a 3.
Well, you can't take the log. You have to raise both sides to the 10 power.
Yeah.
You know, I got the same thing.
So you 10 to the negative 0.35 equals this. You're not taking log of anything. Yeah.
Oh, okay.
That's 0.033.
Oh, right
Well,
here.
it's the same answer, but I mean, it's
Oh, thank you, sir. Yes.
That's why I was taking the log of it.
No, you have to raise both. You have to get rid of LOG.
Yeah, that's how. Yeah, and that's how I got the to the 10th power. See, I took that.
Yeah.
That's how you get rid of the LG. You take the 10th power. And you just I get it.
Because it turns into
So it's neutral, right? It's an HA.
Yeah, I got 8 C's, 8 H's.
We have an exam on Friday.
You're using the base.
I was freaking out because I thought it was on Wednesday and I was taking
So you're using the KLH. Yeah, it doesn't have a charge, so it has to be HA.
Can I see this?
Mm-hmm.
Because I'm kind of
This time you're using the KLH.
How would we be sure if it's in the acid form? Because like I know that's in acid form because I looked at it. So I'm adding the
Oh yeah, there's no plus on there. Yeah, so this is HA.
This is HA because there's no
So that means that name is HA.
That's HA.
So in your
Plus, and that's when you know it's.
that's when it's A minus.
Oh, okay.
I just wasn't sure. So since it's an HA, we're adding the
You have to. It's the only thing that will react with an acid is an OH minus.
finding the moles, HA.
Mm-hmm.
This whole
Yes.
formula or
Yes.
minus?
No, that whole formula. This has to be the neutral compound. That is HA, and that's what they masked out. That many grams of that stuff. It's always of the neutral form. It's always of the neutral form. It's in the bottle.
Other than that.
Uh-huh.
For question 3, for the peptide hydrochloride, I found.
Okay.
Alright, so where would the hydrochloride come
The chloride means that you have a Cl minus right here.
in? Okay.
So that makes it a neutral compound. So this, in this case, this is the acid form. And that chloride is just going to be a little spectator ion. But without that chloride, you can't get this acid form into solution. So that's why it has to be a hydrochloride.
Okay.
And if you want to convert this into moles, you have to add a Cl to this thing.
Okay, so I add hydrochloride and I'll add the KOH.
So what structure? If you have piperidine hydrochloride, that means you have this structure there, right? With a little Cl. What is this? The acid form or the base form?
That one itself?
This one. This is the acid form. So you're starting out with the acid form. So you can't. It'll only react with the base.
Oh, okay. So, okay.
So then you have to convert it.
Would it be HCl? Okay.
Yep.
Are we still using the same equation?
Mm-hmm. Yeah, we're gonna use that for all of these.
Right?
No, it's moles. That's the moles of the base over the moles of the acid. Yep, every single time.
It'd be the same, right? The moles of the conjugate base.
It's always Henderson-Hasselbalch. It's always the moles of the base over the moles of the conjugate acid. Yep.
So we were right?
Yeah.
And that is from the Ka.
That's from K.
Yep. But we're not going to mess with the Ka reaction. But we're going to use its relationship. Yeah. Oh no, you can't. Because I'm not quite ready with the exam yet.
Okay, so what time?
If we need to use the base,
When I'm done, it'll be done by 4. Should be done sooner.
the right formula for
Phenylacetic acid. What is phenylacetic acid?
So did you give 0.031?
Yeah, it's neutral. So that is the HA form. So it can only react. HA can only react with this. So it would be HA plus this makes what? Yep.
Yeah, I just have, I think I would have to.
A for effort.
Okay, we should probably make sure everyone's on the same page for this one. So this guy corresponds to HA or A minus. It's HA. So that means which one's going to react with HA? KOH or HCl? KOH. So you have to have HA over here and OH minus. It's going to make what? Water and A minus. Very good. Okay. So how about question 3? We only have a couple minutes here. Let's make sure everyone's on the same page here. This guy. Let's make sure everyone has these questions set up. So I think you've been working long enough on question 2 that you've got this reaction and you did the mole table on it, right? Question 3, let's make sure everyone's got it set up right. Is piperidine hydrochloride stand for the conjugate acid or the conjugate base form? Adriana says the conjugate acid. It's the acid form. It's the acid form. Look at the table. It has a plus, but it's the chloride. So it makes it a neutral compound if you have the chloride in there. So it's corresponding to this one. All right? So what's the reaction? It's going to be HA, well, same one as above, right? All right. Now, the only last place that I really think you can screw up is what is the structure? What is the chemical formula of piperidine hydrochloride? Right? Just exactly how it is in the book, except what? One slight addition there. Add a Cl minus onto it. Yep. Find it in the book, and just add whatever it is in the book. It's got a plus on it somewhere. Stick a little Cl minus by it. That's it. That is the structure. So when you find the molar mass of it, it's everything that's here and the chloride. If you don't include the chloride, you're going to be way off in the molar mass. You'll be way off on the moles. You'll be way off on everything. Yes?
Okay, so I found out what my X was, and so we're going to convert it to milliliters, but if you go back to the mole table, it's minus X.
Yeah, it all react. It's the amount that reacted.
So I can just leave it as X by itself?
It's just X.
Okay.
It's the amount that reacted, and it is technically it's negative because it disappeared right away.
Right, but I just kind of ignore the negative.
Yeah.
Okay.
So our next class period is review. And then Friday is the big exam. So come by if you have some questions.